Angeba Sojola here. In this video, we'll be basically discussing a device that is known as the electrolyzer. Now, an electrolyzer is quite a very important component in the value chain of producing hydrogen, right? Now, an electrolyzer is fundamentally a device or a machine, right, that uses a strong current, right, direct current to split water into its two elements. Number one, hydrogen. Hydrogen basically collects at the cathode, right? And oxygen collects and congregates at the anode electrode. Now, there are different types of electrolyzers that I've come across, but specifically I've come across about three. Number one, it's known as the PME, which stands for proton exchange membrane. Number two is basically known as an alkaline electrolyzer. Number three is known as a solid oxide electrolyzer. Now, let us begin with number one, the PEM, which basically stands for the proton exchange membrane. Now, in this device, you basically find, right, two electrodes, which are fundamentally divided by something called a membrane. This membrane only allows gas to pass through it. It doesn't allow any liquid. Now, you pump water into the side where the anode is, right? Now, this water is split on the anode side, right? Then the proton, right, which is fundamentally the hydrogen, moves across the membrane because it is gas in form and it blocks liquid or water, right? It moves through the membrane towards the side where the cathode is positioned, right? Now, when it reaches there, it actually connects with an electron, which moves all the way from all around the circuit to come together with the proton in the electrode that is known as the cathode, right? Now, this is how fundamentally hydrogen is formed in the proton exchange membrane, right? Number one, the problem with this device is that it is expensive. It might be efficient, right, in producing a high concentration of hydrogen, but it is quite an expensive technology to use, and you need to replace it every 5 years. But it is a technology that works, but it is quite expensive. Now, number two is known as the alkaline electrolyzer. This type of electrolyzer is quite a reliable electrolyzer. It is quite durable. It can perform at high temperatures, and it is low cost. It's quite cheap to use and to manufacture, right? Now, in this type of electrolyzer, the alkaline electrolyzer, right, you need to be able to use something called an electrolyte, right? Something that will promote the chemical reaction which will push for hydrogen generation, right? So now you find two types of electrolytes that you can use in this device. Number one is known as the potassium hydroxide. Number two is known as the sodium hydroxide. Now, you mixed one of these two with water, right? At a concentration of, let's say the electrolyte is at a concentration of 30% and water is at a concentration of about 70. So you take the electrolyte and mix it with water, right? And then you put your electrodes into that solution, right? That electrolyte. Now, the electrodes are separated by something called a separator or a diaphragm. It works similar to that of the membrane in the PEM, But the difference here is that this one is number one, porous. It is electrically insulated, right? And it fundamentally prevents gas from crossing over to the other side. So basically, this is the alkaline electrolyzer. And the third type of electrolyzer that I've come across is basically known as the solid oxide. The solid oxide does not produce hydrogen, right? The solid oxide basically takes carbon dioxide and then separates one oxygen from it and then remains with the carbon monoxide. That carbon monoxide is known as synthetic gas, right? Now, this synthetic gas is the gas you need to be able to produce fuels, jet fuels, and a lot of other products that we tend to use in the current world, right? So basically, solid oxide, it is to create not hydrogen, but sign gas, right? Synthetic gas, which is fundamentally CO, which is known as carbon monoxide. Thank you for this opportunity that you've given me to present electrolyzers to you. Hopefully, I'll see you in the next video. Thank you.